Good day, everyone. So, if you are given a question of this format under Kirchhoff law or under a network theory, if you are given a question of this format, how are you going to go about it? Let's read the question. Using the figure below, if the load resistance, that's what your RL, is varied from 0 to 1 ohm steps, calculate the power dissipated by the load in each case, and also plot your graph. When you look at the figure, it gives you your voltage as 6 volts, and your load resistance as you were given your internal resistance as 2.5 ohms, and you have your load resistance here. So he has given you the steps of your load resistance as from 0 to 1. In what steps are you going to go from 0 to 1? In 0.5 steps. So from 0 to 1 in 0.5 steps. So meaning that when you go from 0, it's 0 plus from 0, if you are going with 0.5 steps, it's 0 to 0.5, you come to 1. So you are going to go in these 3 steps from 0 to 0.5 to 1. So how are you going to solve it? You're going to use the formula whereby current I is equal to your E, voltage, all over your internal resistance plus your load resistance. And when you are finding power, it said calculate the power dissipated by the load in each case. So meaning for 0 and also in 0.5 and also in 1. So the power is going to be equal to your current squared times your load resistance in watt. This is the unit of power. So your answer, after when you are finding the power, the answer should be in watt. So let's quickly go through it. So at 0, so we are going to start from 0. I is equal to your E all over R plus RL. So at 0, your 0 is going to be the RL. So if here is 0, how are you going to write? So your E is 6 volts. So it's going to be 6 out of your internal resistance 2.5 plus 0. That is going to give you 2.4 ampere. You are finding current, so the SI is ampere. So at 0 case, we should find power. So power is equal to I squared RL. So I squared is the current. So you got the current to be 2.4. It's going to be 2.4 squared times RL is 0. So therefore you are going to get 0 watt. So this is for case 1. For case 1. So for case 2, at 0.5, I will be equal to your voltage, that's 6 out of your internal resistance 2.5 plus your RL, that's your resistance load, is 0.5. So your answer is going to be equal to 2 ampere. So you've gotten this one, you've gotten to be 2 ampere. So let's find our power. Power is equal to I squared RL. So it's going to be 2 squared times your RL is 0.5. That's going to give you 2.00 watts. So from here you can pause the video and also try to solve case 1. So you can pause it and try to solve case 1. So at what? Case 1. At case 1, I is equal to 6 over 2.5 plus 1. That's going to give us 1.714 ampere. So we find our power. Power will be equal to 1.714 squared times what? 1. That's going to give you 2.94 watts. So we are going to use these to what? To draw your what? Table. So this is how your table is going to look like. So at case what? 0, at case 0.5, and what? At case what? 1. So at case 0, what was what? Our current. Our current was what? 2.4. And what was our power? Our power was 0. At what? Case 2, that was 0.5. What was what? Our current. It was what? 2.0. And our power was what? 2.00. Power should be in what? 2 decimal places. At case 3, that's 1. Our power was giving us 1.714. And our current was 1.714, and our power is giving us 2.94. So in a question, they told us to what? To plot a graph. So in plotting the graph is what? P to what? RL. So this is how I'm going to plot your graph. So this graph of what? P, that's what? The power. The power, and what? Your what? Resistance load, that's what? Your RL. So let's do 1, 2, 3, and what? 4. Have your 0 here. When the power was 0, the resistance was 0. So you're going to bring your point here. That's what? 0. When it was 2.00, your resistance was 0.5. So here it's what? 0, 1, 2, 3, 4. So where would 0.5 be? 0.5 would be somewhere like in here. But the power was what? 2. So it's going to be like this. So the power is going to be what? In here. So it's what? 2, 0.5. 2, 0.5. So from this one, when the power was 2.94, the resistance was what? 1. So 2.94 is going to be somewhere like in here. The resistance was 2.9. It was 1. So 1 is going to be here. So let's do it. Come here to 1. So now you draw what? Your curve to pass through what? All the dots you've made. So from 0 to this side to here. So this is how your graph is going to look like. So see you in my next video. Thank you.